Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.
Welcome to another episode of the ARC Advisory Group Smart Cities podcast. I'm Eddie Fidler. I'm a transport analyst at ARC, and I'm happy to be joined today by Greg Hintler. He's the managing director of the USA business at the Mobility House. Welcome, Greg.
Hey, Ed. Thanks. Good talking to you. Good being on the podcast.
Yeah, thanks for joining us. So maybe we can start by just having a little bit about your background, and then we'll get into the Mobility House.
Absolutely. Sounds great. Well, so the way I would start this is, and to help you understand why I do what I do, it might help stepping back a bit and starting out with how and where I grew up. You know, I was lucky to grow up in rural southern Germany, close to Munich, the Alps, beautiful lakes, so a very beautiful scenery. And growing up, we always had lots of animals, spent a lot of time in the outdoors, and my dad in particular knew everything about the plants and the critters around us. So early on, I had an appreciation for nature and wanted to preserve it. Later then in high school, I got super into physics, and when I learned about the greenhouse effect and climate change, I, for myself, identified that as being the biggest challenge for our generation. And you know, also the challenge that I wanted to dedicate my academic and professional career to. One of the climate change solutions that attracted me early on was reforestation, so planting trees. For one, because it is a solution that doesn't just create negative emissions, so we can sequester carbon, but it also has lots of other positive effects on biodiversity, etc. And it's also a solution that I felt like I could contribute to immediately. So back in high school, I thus helped with the founding of Plant for the Planet. Plant for the Planet is an organization that raises awareness for climate change and is planting trees. And the organization now is active in over 70 countries, has planted 13 billion trees worldwide, and it's doing really well. But from there, I decided that I wanted to shift my focus of my academic career on the energy and transportation sector, where I saw for myself that I could make the biggest impact on decarbonizing those two sectors through policy and technology. And after grad school, I ended up in the energy sector, first in a consulting company, later with a large independent power producer. And while I was working in the energy sector and doing lots of analysis on emission trends, I noticed that we were making really good progress in the electricity industry. You know, emissions were coming down because we were adding renewables faster and faster and shutting down coal plants. But in the transportation sector, I saw a different trend. The trend was actually upwards in terms of emissions. And in 2015, what happened is the transportation sector actually overtook the electricity generation sector as the sector with the largest share of carbon emissions in the United States.
Right.
And that's when I, decided to transition into the transportation industry because I believe that I'd be able to make the biggest impact there. And now over the past couple of years, I've been with the Mobility House and working towards creating a zero emission transportation and an energy future. So we're trying to tackle both of those sectors at the same time. And we're doing so by creating and developing solutions for electric vehicle charging and vehicle grid integration. Because we strongly believe that if you want to move towards an electric transportation and energy future, you will require very deep integration between those two industries. And we've shown through our product and through our projects on the ground that by aggregating decentralized energy storage assets, whether that's batteries, large scale, utility scale batteries, or batteries on wheels, so decentralized batteries all over the world or all over the place within electric vehicles, and then control how they're charged or even discharged, we can reduce the cost of charging for our customers and create massive economic and societal value. And so that's really our goal, is to provide charging to our customers, and reliable, safe, and easy charging of their electric vehicles, reduce the costs of charging, and reduce overall CO2 emissions.
Okay, so yeah, a lot of this starts with the needs in sustainability that are only growing. But can you talk a little bit about why electrification of transport is happening at all, and what some of the benefits are to that, before we get into how we're optimizing that and integrating it with the grid?
Yeah, that's a great question. Absolutely. I'll dive into a little bit. Why is electrification happening? To me, there are numerous reasons, but technology advancements, regulation, and societal perception of EVs are the main drivers. So if you look particularly at battery technology has significantly improved over the past 10 years or so, and prices have plummeted. And since batteries are the most expensive part of an electric vehicle, the total cost of vehicles has come down significantly and is approaching cost parity, at least in some segments, and is predicted to do so, in the next few years in more and more segments. The second point here, regulation plays a huge role. As mentioned before, transportation is now the number one source of CO2 emissions in the United States and in many other places, and is also responsible for lots of air quality issues, particularly in urban areas. And, considering the dire situation that we're in regarding climate change, there's now a much greater focus on decarbonizing the transportation sector. And for instance, several countries have now set laws in place that will outlaw ICE vehicles, so internal combustion engine vehicles, gasoline vehicles. In the future, I think France, for example, has done so with a 2040 timeframe. And then there are other players such as cities all around the world that are starting to block ICE vehicles from entering their city centers. So you won't be able to drive a non-electric vehicle or a non-low emission vehicle into city centers in the future. And then finally, I think the perception of EVs is really changing massively. A few years ago, EVs were seen as vehicles for do-gooders or tech fanatics. But now EVs have become a status symbol, and they're even becoming more and more mainstream. And when we think about that, that's really hugely due to companies like Tesla, who've demonstrated that EVs are simply a better technology, that EVs can perform better performance, they have a better driving experience, they're just more fun, better pieces of technology. And then, if you take, for instance, the Super Bowl Super Bowl commercials as a good barometer of social trends, we know that 2020 is the year of where electric vehicles have become mainstream. GM announcing an electric Hummer, then the Porsche commercial showing off their Taycan, or Ollie really nailing it with Arya Stark singing "Let It Go," referring to the age of internal combustion engines.
Mm-hmm.
So I
and
think
you had Ford with their electric Mustang.
Yeah, exactly.
It's gorgeous, and people are falling in love with that thing. It's actually the high performance versions of that are fully back ordered already.
Yeah, it's super exciting.
Yeah, so a lot of these cultural shifts, among others, so those are really big on the sort of private and light duty side of things. But the other side, and which arguably has even more of an impact at this early stage, is commercial, right? Both light and medium duty, and even sometimes in heavy duty. So because electric vehicles are so much cheaper to operate in terms of fuel savings and maintenance, these guys are really seeing economic value. So, we have FedEx and DHL and UPS ordering all these commercial electric vehicles. You had corporate fleets changing over, and Amazon even just ordered 100,000 electric delivery vans for its fleet. So for those folks, it might be less about fun and performance as much as it is about operating costs, but the proof is there. I mean, they're all moving in the same direction.
Yeah, I fully agree. The reason why this is all happening now is for large fleets mainly driven by economics and regulation. And the economics piece is because we've had those technology advancements. We now see the cost of the vehicles coming down significantly. And because we have lower operating costs for electric vehicles, lower maintenance costs, lower gasoline costs or fueling costs, we now see the economic case making more and more sense across different types of fleets. And the second piece is all the large companies know that some type of carbon regulation will be coming down the line, and they're preparing for that type of feature. And then, as mentioned, there are places where in order to be able to operate, you will simply have to have a zero emission fleet. So take London or Paris is I think also talking about this as an example, where you simply cannot access the inner city if you don't have a zero emission vehicle. And so for these large companies, that means their core business is in danger, and that's why they're making those changes now.
Yes, it's not just that it is already happening in limited ways, but everyone knows that these regulations are coming, or we're at the position now where they've been announced for 5, 10, 15, 20 years from now. And so you may as well get in line and preempt those shifts, right? We actually had the head of sustainable mobility at IKEA or Inc. Group here on the program a few weeks ago. And, they've committed to converting all of their home deliveries to sustainable transport methods in the next 5 years. And one of the points that this person made was, in a lot of cities in Europe, because of that diesel ban from the central city, their trucks or their contractors' trucks simply will not be able to deliver their products. Period. So it's, there's something to be said about being proactive and being future oriented and sustainable and responsible, but you also just have to run your business. And so it's kind of all coming at you from different directions, right, as a business owner, but it's all pointing in the same way. You know what I mean?
Exactly. Yeah. It's, it makes sense. It makes sense now, economically. Regulation is there that is pushing. And then I think the societal pressure is there as well.
Yeah. And so there's all these benefits for fleets, but the huge caveat here is charging. And we know that fleets can save a lot of money and provide better service to their customers and a better experience for their operators with EVs. But when they all go back to the depot, they all plug in to charge, and they get clobbered with a demand tariff from the utility. All those savings can be wiped out. So that's kind of where vehicle-to-grid integration comes in, right? So can you talk a little bit more about the grid side and renewables as well?
Yeah, happy to. I think when we talk about vehicle grid integration, and it helps to look at two of the macro trends that are currently changing both the energy and the transportation industry. So one is that shift from fossil fuels to electric in the transportation sector, and then, as discussed earlier, in the energy industry moving towards electricity generation with renewables, mainly wind and solar. And that's, on the renewable side or on the energy side, that's because the new build cost of renewable generation today in many regions is actually cheaper than existing fossil fuel generation. And this trend towards renewables is only going to accelerate. And both of those trends, so transportation electrification as well as moving towards renewables, those are great trends, but they pose a few challenges. So for instance, in places with lots of renewables, like California or Hawaii or Germany, we now have periods where we produce more electricity with renewables than we can consume. So there are times of the year where we have to shut down wind or solar plants because the electricity that they produce simply cannot be taken up by the grid because there's not enough demand. So in Germany, for instance, last year in the Q1 alone, 3.3 terawatt hours of renewably produced electricity had to be curtailed. In California, it was around, in the same time, it was around like half a terawatt. But the predictions are that by 2030, in California alone, you will have about 10 terawatt hours. That's 10 billion kilowatt hours of curtailed renewables. That's enormous. That's enough to drive about 2 million vehicles, electric vehicles, for a year on clean energy that otherwise would have gone wasted. Mm-hmm. So that's a huge issue.
Then it really interferes with the bottom line of those distributed energy, resource companies.
Absolutely. It has a negative impact because they are not getting paid for that electricity that is being curtailed, or only partially, depending on what kind of policy environment they're in.
Right, exactly.
The other trend, then, the electrification of transport, poses also challenges to the grid. Imagine the millions of electric vehicles that are going to be on the road, all plugging in to charge in the late afternoon when, folks are coming back from work or, finishing their shifts, delivering packages or delivering people back from work or, in a school bus. All of those vehicles plugging in at the same time, if not managed properly, will lead to a massive spike in demand of electricity in the late afternoon. And that could exacerbate the challenge that grid operators already face today to meet this late afternoon electricity demand. And just at those moments when the production of solar is dropping. In the utility world, a lot of people are talking about, coining this phenomenon, as the duck curve. And, the estimates are really that, that will, become even worse if we don't find solutions to store the electricity or to more intelligently manage demand.
Right, exactly. The duck curve is where midday your solar generation is working, so your net load sinks down in a bit of a U shape, and then as the sun goes down, but everybody comes home and starts using their appliances and lights and what have you, you have a steep incline in your net load. But then on the EV charging side, we know that there's a phenomenon called the shark curve when everyone comes home just about that same time, 5 and 6, and plugs in their vehicles. This is on the residential side, of course, mainly, but also on the fleets. It's just the fleet side, it's a little bit more mission profile dependent. But when you have that shark curve overlaid with the duck curve, your grid and everybody paying demand charges is in for a lot of trouble.
Yeah, exactly.
So talk about the solution to this. Talk about vehicle grid integration and how all of this sort of challenge and disruption can actually be used as an opportunity.
So smart charging, including all kinds of different forms of vehicle grid integration, could unleash synergies between the transportation and a low carbon electricity grid. In fact, the scientific community and we at the Mobility House, we believe that batteries in electric vehicles are going to be instrumental in integrating those high shares of renewables in the power system. As we discussed earlier, generating lots of clean power is good news, but it means that we need a lot of flexibility in the system to balance out that volatility, to address that, shark fin, the duck curve. And we need to store energy when there is a lot of wind, a lot of sun, and for times when there is little wind and little sun. And we need to be able to shift around how we consume energy. And that's really where vehicle grid integration comes into play, because most vehicles today are sitting around for 90% of the time, so are really only in use for 5 or less % of the time. The remainder of the time, those vehicles could be used for some other purpose. For instance, they could be functioning as a source for backup power to a building. They could shave off expensive load peaks in a building or even on a grid scale. And they could charge with cheap and clean electricity during the day and then return even some of that electricity back to the grid or back to a building. And finally, they could also participate in the energy markets and provide different services such as, frequency control, and through that generate revenues. So make money for the vehicle owner. That's the concept of vehicle grid integration and vehicle to grid technology that we're trying to make a reality. So just to give you a sense of the opportunity here, the battery capacity that will be available to do all these great things is massive. So, IRENA, the International Renewable Energy Agency, estimates that we'll have about 1 billion electric vehicles on the road in 2050, if we want to meet the Paris goals, or the goals we as a global society community have set for ourselves in terms of carbon reductions. And those billion vehicles would be equivalent to approximately 14 terawatt hours of battery capacity that could be available to provide different types of grid services. And that is far more than the 9 terawatt hours of stationary storage that's predicted to be available to do that. So the good news here is there will be enough flexibility out there to balance out the volatility of renewables. And we believe that, the electric vehicles will be the main source of that flexibility for the grid in the future. But to enable that, we need technology, vehicle grid integration technology, and including vehicle to grid technology, which can create tremendous benefits both for the vehicle owner and society. As I mentioned before, it could generate revenues for the vehicle owner. We estimate that VGI can generate up to $1,000 per year per vehicle, per car, and is significantly more for larger vehicles. And then, in comparison to a non-managed charging scenario, vehicle grid integration could also yield tremendous potentials for emission reduction. So in Germany, for instance, we've done the analysis and we estimate that VGI could reduce CO2 emissions by 1.7 tons per vehicle per year. So tremendous benefits in this technology.
Wow. Yeah, and part of that, as I understand, is by smoothing out demand on the power grid, you alleviate some of the need of having to start up and run those peaker plants. And a lot of those are, of course, based on fossil fuels and contribute to emissions.
Yeah, exactly. We see this as a natural progression. A lot of that we can already do today. So if we can control when vehicles charge, we can try to charge the vehicles during the day when there's a lot of electricity available from solar, for instance, or during periods of time where there's little demand. And then not charge during times where there's high demand, where there's little clean energy available. But in the future, there will be cases where it will make sense to do more with the batteries, to do more in terms of vehicle to grid services. But it will really depend on the use case.
Okay, so that's where we're at right now. It's that sort of managed charging, the one-way unidirectional charging from the grid to the vehicles, but you can simply offset the charging time based on when it's most expedient for all the actors involved, the grid and the EV owner. So there are lots of pilots and projects around that right now.
That's correct.
But you're saying the next step in the evolution is going to be bidirectional charging and how to manage that. So what are the barriers to doing that? And what are you guys and your contemporaries doing to further that?
Yeah, I'm happy to shed some light on what integration could look like and what we are doing here, and maybe provide some examples of what this could look like. So in order for electric vehicles to provide different services to the grid or to a building, we need technology that enables controlling how and when, how much and when vehicles are being charged or even discharged. And then furthermore, we need the ability to aggregate the load and flexibility of each vehicle across millions of vehicles. And then the ability to decide what do we do to make the most to make the most money with the available assets. So considering the battery state of charge, departure time of vehicles, cost and value of different energy services, and so on and so on. And that we at the Mobility House we've built a charging and energy management platform called Charge Pilot, with which we already today help charge hundreds of almost 100 fleets, everything from last mile delivery services to buses, and we help them control their charging to reduce their cost and the emission of operating their fleets. But now if we look out into the future of, what does this look like on a system level? I can take you on a quick excursion to an island off the coast of Portugal in the Atlantic called Porto Santo, where we work with automaker Renault and a local utility to demonstrate how you can use electric vehicles to help accommodate a more renewable and help accommodate more renewables on the grid. So that island, like many islands, was importing a lot of diesel fuels, and rather than putting in an undersea cable to balance out the renewables that they put in to reduce the amount of diesel they're consuming on the island, we said, let's bring in electric vehicles and smart charging technology, Charge Pilot, in order to help balance the volatility of the renewables on site. So now the local utility sends us a signal to either ramp up or ramp down charging or even discharge, depending on the situation on their local grid. So whether there's when the sun is shining, the wind is blowing, and there's a lot of clean electricity available, we try to charge all the vehicles and the batteries on site. And when there's little wind, little solar, and a lot of demand, we try to throttle down the charging of the electric vehicles, and maybe even discharge part of the batteries of the bidirectional capable vehicles. Always trying to keep in mind the user experience. So the main purpose is always make sure the mobility needs of a driver are met. Make sure that when they need to depart, they're ready, they have the enough state of charge to get where they need to get. And considering, all these different parameters, to make sure that you generate the most value to both the vehicle owner and society as a whole.
And so how do the drivers interact with your software? So they must input their particular schedule or upcoming needs for their vehicle, in the same way that the grid inputs their own needs.
Yeah, that's correct. And for us, we mostly work with fleets because we believe that, fleets are right now the places where vehicle grid integration is or this type of vehicle grid integration is done much more easily. So we have more predictable schedules and can pull in scheduling information that's already available from different fleet management system into our system. So there is no additional burden for the drivers.
Mm-hmm. Yeah, that makes a lot of sense. So we talked about a case study and a successful early case study for vehicle grid integration. But I'm wondering if you could tell us about what some of the challenges are for scaling this up, for expanding projects, and for bringing this everywhere that it could be.
Yeah, it's a great question. I think that there are a number of challenges out there, but three big ones stick out to me. One is regulation. Right now, interconnection of vehicles as a grid asset is super cumbersome, or in many cases not even possible. Then we don't have good access to different energy markets for electric vehicles. The compensation for vehicle grid integration services is either too little or not defined at all. So from a regulatory perspective, a lot of things need to happen to bring this to mass scale. And there are jurisdictions where this is more evolved than others, but all in all, even in the most advanced places, I think there's work to be done. The second piece is the technology, especially when we're talking about the vehicle to grid capabilities, so the bidirectional power flow capabilities of vehicles needs to advance. And there are right now only very few commercially available vehicles that have that capability. And the cost of the chargers, of bidirectional chargers right now is prohibitively high. So that needs to come down. But all in all, we're pretty confident that those challenges can all be addressed in the coming years, and that VGI will play a more significant role in the future of our energy systems. But it will be highly dependent on the application of the fleet, the use case, the geography, and the situation of the grid in that specific region.
Okay, so what do you see as the roadmap for this space in the near, medium, and long term?
Yeah, the roadmap is staged. Where in the past we tried to ensure that vehicles are just simply charged. It was all about make sure a vehicle is reliably charged. Today, the priorities are still that. Plus, on top of that, we're trying to optimize charging such that we reduce the overall cost of charging. So upfront, reduce the cost of charging by not even having to install as many chargers. not having to put in as large of a grid connection as you might have to if you don't manage your load. And then while you're charging, shape of peaks and shift your demand and so on. That's optimizing of charging today. What we're doing with, as I mentioned, almost 100 fleets in different places with our Charge Pilot platform. And in the future, and that will be staged, is vehicle grid integration. There will be cases where this is going to happen, I think in the 2021 timeframe. So everything as it relates to vehicle to building and providing different types of resiliency. We're seeing, especially in California, a lot of interest in that related to the fires and the power shutoffs from last year. But then more cases where we need markets to evolve, regulation to evolve, and so on. So the vehicle to grid use cases, they're still a few years out, in my opinion.
So this area is really exciting. There's a huge promise here, a lot of value for all parties, but there are definitely some technological and policy roadblocks along the way that we're working on.
That's correct. That's how I would characterize it.
Mm-hmm. Great. Well, it's an exciting space to be in, and we'll be watching Mobility House and this industry very closely. So hey, Greg, thank you very much for joining us and imparting some knowledge and talking to us about your case studies and your thoughts on the space. And we'll hopefully have you back soon.
Thank you so much, Ed. Great talking to you again, and looking forward to continuing the conversation.
Okay, thanks a lot. Take care.
All right, take care. Bye-bye.
Broadcasting from Boston, Massachusetts, the Smart Cities podcast is the only podcast dedicated to all things smart cities. The podcast is the creation of ARC Advisory Group's Smart City practice. ARC advises leading companies, municipalities, and governments on technology trends and market dynamics that affect their business and quality of life in their cities. To engage further, please like and share our podcast or reach out directly on Twitter at Smart City Viewpoints or on our website at www.arcweb.com/industries/smart-cities.